Welcome to this deep dive into the Isometric Hub and Monk dialogue system. We'll walk through the key code that makes this work, starting with the foundation. The isometric grid itself. The heart of any isometric system is the coordinate conversion. Here we have two functions that do the heavy lifting. Grid to world POS takes a grid coordinate and projects it into isometric screen space using the classic diamond projection formula. X minus y for the horizontal axis and x plus y for the vertical. The inverse function, world to grid pose, reverses this math so we can convert mouse clicks back into grid coordinates for gameplay logic. At the top of the file, we define our isometric constants. The tile scale of 1.6 stretches our tiles horizontally. The tile height is exactly half the width, which gives us that classic 2:1 isometric ratio. These constants propagate throughout the entire system. Creating individual tiles is where things get interesting. We check if this tile is part of the center Buddha area or the monk's position at the top. If it is, we set the alpha to 0, effectively hiding the tile. The grid logic still treats these as valid positions, but visually, they're replaced by our custom art. We also scale each sprite to match our isometric dimensions. The create grid function ties it all together. We iterate through every row and column, creating tiles and storing them in our grid array. After the base grid is complete, we layer on the special elements: the Buddha center, the monk at the top, and the animated stream row at the bottom. For the Buddha statue, we first check if a tile is part of the center 2x2 area using a center tile. Then add Buddha center calculates the center position between those four tiles. Notice the float offset, which raises the Buddha art slightly above the grid for a hovering effect. The sprite is scaled to span the full 2x2 tile area. The monk placement is simpler. We lock it to grid position 00, which is always the top of the diamond in isometric space. The tile underneath is hidden, and the monk sprite takes its place, scaled to fit a single tile. For the animated stream, we load two stream textures. These will be cross-faded to create a breathing, flowing water effect without jarring frame changes. The stream row function creates a container node and adds two sprites, one for each texture. The first starts fully visible, the second starts invisible. Then we set up a looping tween that fades sprite B in while fading sprite A out, then reverses. Using assignees creates a smooth, organic breathing rhythm. Now let's look at how everything floats. In the bonfire hub setup, we create a dedicated floating layer and attach the grid and all pieces as children. This is a classic optimization. Instead of animating every tile and piece individually, we move one parent node. In the process function, we update a float time counter and apply a sine wave offset to the floating layer's Y position. The amplitude and speed constants control how dramatic the bobbing effect feels. Simple, but it adds a lot of life to the scene. Click handling is where the interactivity lives. When the player clicks, we convert the mouse position to the floating layer's local space, then to grid coordinates. We check if they click the Buddha tiles to open the upgrade menu, or the monk tile to trigger dialogue. Otherwise, we teleport the player to the clicked position. The Buddha interaction uses a list of all four center tiles. We check if the player is adjacent to any of them. If so, we save their position and transition to the blacksmith menu scene. This adjacency check allows interaction from any surrounding tile. Monk interaction is similar, but adds a gating check. We only allow one quote per level. If the player already talked to the monk on this level, we return early. Otherwise, we get the next quote, update the last level tracker, and display the message. Here's our quote. Bank. 30 Zen-inspired messages that fit the game's meditative theme. Each one is designed to be memorable but not preachy. The player will see these rotating throughout their runs. The session state for quote rotation lives in game state. We have a shuffled quote pool and a tracker for the last level where the monk spoke. This data persists within a session but resets between game launches. The quote selection logic is elegant. If the pool is empty, we refill it with all quote indices and shuffle. Then we pop the first index from the front. This guarantees every quote is shown once before any repeats, while still feeling random to the player. Displaying the quote uses a minimal UI approach. We create a control container with no background panel, just a centered label. A tween waits 4 seconds, then fades the message out over 2 seconds before cleaning up the node. Clean and unobtrusive. Sprite anchoring is crucial for isometric games. This function calculates an offset so that a piece's feet align with the tile center, regardless of sprite size. We handle both static sprites and animated sprites, checking their texture dimensions and scale. The result is applied by the piece manager when positioning. In the piece manager, when we create a piece, we call grid to world anchor, which internally uses our anchor offset. This ensures consistent visual placement across all piece types without hard-coding offsets for each one. The UI setup creates our persistent buttons, continue run and back to menu. These are anchored to the bottom right corner. We also add a hint label at the top left that updates based on whether a controller is connected. Finally, the hub music system. We stop any main menu music that might still be playing, then create a new audio stream player. We try loading the music through Godot's resource loader first. If that fails, we fall back to direct file loading. The music is added to the tree root so it persists independently of scene changes, and we clean it up when exiting. That covers the complete isometric hub and monk dialogue system. The key takeaways are: use coordinate projection for isometric math, layer custom art over hidden grid tiles, animate one parent instead of many children, gate dialogue to prevent spam, and use shuffled pools for non-repeating randomness. Thanks for watching. If this content interests you, please subscribe to see more. I try to upload game dev vlogs every day,